Okay, we have a question here. 2007 question number 87. It says if the ratio x is to y is equal to 3 is to 5 and y is to z is equal to 4 is to 7, find the ratio x is to y is to z. Okay, so I want you to pause the video, try to solve it, and then we can compare the answers together. Okay, I believe you paused the video and you have your answer. So let's do it together. Let's take solution. Let's take solution of this. This is something that we need to know, very important. Let's have the values of each of these out first. The value for x in x is to y. There are two sets of ratios. We have the first x is to y, and that value, we have the value x is to y, which is equal to 3 is to 5. Equal to 3 is to 5. Okay, and we have another one. Let's put a comma here. We have another one, another set of ratio. Still, this one is y is to z. Y is to z, and y is to z here is equal to 4. Is equal to 4 is to 7. 4 is to 7. Okay, let's have this 4 and 7. That's fine. 4 is to 7. Then we are asked now to find this. Now there is a common problem here, and we need to fix this common problem before we could now have arranged this ratio. And in types of ratio during our introductory class, we talked about equivalent ratio, just as we have equivalent fraction. All right, so let's observe something. Now for x, we have x how many times in this equation? Is there any other x again? No other x. And the only value, meaning we have one value for x, and that one value for x that we have is this 3 here. This 3 is the only one value that we have for x. This 3 is the only one value. Okay, now when it comes to y, we have a challenge. Observing y, we have one y here, and the value for this y here is this 5. The value for that y is 5, and also we have another y here, and the value for this y is 4. Okay, something is out here. Let's introduce our 7 back. Good. So this is what we want to. We need to fix this. We need to fix this. I want to write this under this order fraction. Let's rearrange this fraction. Let's rearrange the ratio of fraction. Pardon me. All right, let's rearrange. All right, let's look at something very closely. Let's look at something closely now. Y here, the value for y in this first ratio is 5, right? Great. Now the value for y in this second ratio is now what? 4. If I should circle the y's together in this one, and then now circle this other y together, you'll see very well that their values are not the same. Their values are not the same. This other y here, they have different values, 5 and 4. So what we want to do is for us to ensure that y has only one value. And how do we achieve that? First thing we're going to do will be for us to multiply out these 4 and 5 by taking multiply out the 4 and 5. That will be a common the LCM. So what we are saying here is we need a number, particular number that 5 can divide and 4 can divide. If we want to take the multiples of 4, for instance, we're going to take the multiples of 4. Take the multiples of 4. Multiples of 4 will be 4, will be 8, will be 12, will be 12, will be 16, 20, 24, 28, and the list goes on and on. All right. And if you come to take the multiples of 5, the multiples of 5 will be 5 itself, will be 10, will be 15, will be 20, will be 25, will be 30, the list will go on and on. Now, any number that we see here and we also find here, it means that is a common multiple that 4 and 5 can divide. All right, and looking at this number, the only number here is 20. It's 20. So 20 is the only common number that is here and the only common number that is here, meaning 4 can divide 20 and 5 can divide 20. Okay, so that was the shorter way of us just multiplying, where we have the two y's together, this y in this ratio and this other y in this ratio to be 20. And I've just shown you like the lowest common multiple that we have in 4 and 5 is 20. Okay, now having done that, the next thing that we are going to do now will be for us to start conversion. Like for x is to y, we are doing the conversion. That's the same thing as saying 3 is to 5. 3 is to 5. Okay, so for this one, we are going to convert. We have 20 here. Now, what we are going to find out is which number are we going to multiply with this 5, this 5 here to give us 20. That number will be 4. That number will be 4. So we are going to multiply everything here by 4. So here will now become 3 times 4. 3 times 4 is 2. We now multiply this other one, 5 times 4, and 3 times 4 we know is 12. So here becomes 12 is 2, and then 5 times 4 is 20. So we're able to have y here as 20. Great. Now let's pick the next ratio, and that is this other ratio we have, y is to z. Y is to z, and y is to z, the value that we have is y in this case is 4. Great. And then z is what? Z is 7. Beautiful. Z is 7. Great. Now we are going to change. Look at y is 4 in this case. Now we ask ourselves, we had a common multiple of 20. Now what are we going to multiply with 4 to give us 20? That will be 5, meaning we are going to multiply this everything here by 5. Now here will become 4 times 5 is 2, and 7 will now become 7 times 5 as well. 7 times 5. Great. Now 4 times 5 is 20. Now say 20 is 2, and then 7 times 5 is what? 85. Observe something. Now we've been able to establish that our y in this ratio is 20 and y here is 20, meaning everything is on the same, let me say everything is the same, Okay, and here x is 12. So we were asked to find this now. So we can now say that x is to y is to z is now equal to the new values. We will be able to change x to 12. So x will pick up the new value, becomes 12 is to y is the new value. The new value of y in both ratios is what? 20 is 2, and z, the new value for z is what? The new value is 35. So meaning our new ratio is now equal to 12:20 to 25. Now we check for it in our option, which one has 12:20 to 25? Option B, and that's the correct answer. So it was simple. We observed that there's an issue, a challenge. Why in this first equation, this first ratio, why in this first ratio was 5, and then why in this second ratio was 4. Because here 5 and 4. So we had an issue. We needed to convert them to the same value. We wanted y to be the same value in the two ratios. And for us to do that, we needed multiple of 5 and multiples of 4. And we needed the least common multiple, meaning a number that 5 and 4, the smallest number that 5 and 4 can divide comfortably. That is more like the LCM. So the LCM of 4 and 5 is 20. Great. So now having that 20 is the LCM of 4 and 5, we now move down to this first ratio, 3:5. We asked ourselves, which number are we going to multiply with 5 to give us 20? And that number is 4. We multiply is 4. So we multiply 5 by 4. We use that same 4 to multiply 3. 3 times 4 is 12. 5 times 4 is 20. Now put the next ratio, y is to z, which is 4:7. In this ratio, we ask ourselves a question: which number are we going to multiply with 4 to give us 5? To give us 20. That number happens to be 5. We now use 5 to multiply everything. 4 times 5, and that is 20. 7 times 5, that is 35. So the question was for us to find the ratio x is to y is to z. We've been able to have a new value, so we just arrange our new value for x is now 12, our new value for y in both ratio is 20, our new value for z is 35, and that was the correct answer. Okay, so that will be it. See you in the next class. Bye.